Hey guys, Wes here. I've been getting a lot of questions lately about how to set up a reverse proxy using nginx. So in this video, we're going to dive in and use a combination of Docker Compose with nginx to create a reverse proxy for a few backend services. We'll use Python to write our backend services, and we'll also serve up a front-end application in Vue. So with that, let's go ahead and get started. Okay, so we're going to be working within a project directory called Weather Report. And the strategy here is just to try and demonstrate how we can use Docker Compose to orchestrate a number of different services together, including an nginx reverse proxy, which will sit in front of a Vue application and two other Python services. So to do this, we're going to work in a file called dockercompose.yaml. So I've got the project pre-built here just for ease of explanation and following along. If you'd like to check out the code, I'll post a link to the GitHub repository in the description of this video. But to give you an idea of how this project is laid out, we've got a Docker Compose file at the root of our working directory here, our project, and then we're going to have four separate directories. We're going to have a Precip service directory, reverse proxy, temperature service, and weather report. And each of these directories or subdirectories of our project directory here will be used to house the logic for each of the four services that we need to orchestrate. So let's begin by taking a look at our dockercompose.yaml file. So I'm going to come over here and we'll just take a look at what this file looks like. We're going to be using syntax version 3 of our Docker Compose file, and then we're going to define our services. And so we're going to have four services here. We're going to have a reverse proxy, a weather report, a temperature service, and a Precip service. So let's take a look at these one by one. Our reverse proxy will be using an nginx image, specifically version 1.17.10, and the container name here is reverse proxy demo. It actually depends on other services orchestrated by Compose here, so it's going to depend on weather report, temperature service, and Precip service. And then we're going to use a simple volume mapping here between our reverse proxy subdirectory nginx.conf and etc nginx.conf on this container. So volumes in Docker are a way that we essentially allow for data to persist across the lifetime of a container. So we want our data to be able to be saved, if you will, if containers are ephemeral. So if I spin up a container, have that container read some configuration values, maybe create some files, and I'd like those files to persist after the container itself is destroyed, say if it crashes or if it's brought down during some scaling event, then we can actually just map this local file, in this case just a simple nginx.conf, to the location where it would be read from inside of the container itself. Then we're going to map port 80 locally to port 80 on the container, because our nginx server running here will be listening for requests on port 80, and in order for us to hit port 80 in that container, we're going to map that to our own local host, port 80. Now we'll take a look at our two Python services here, or actually first we'll look at our Vue app. This will be the service we use to generate weather reports. So it's called Weather Report, and it is a weather report named image with a container name Weather Report, and we're going to give this one a build context. So we're actually going to create our own Docker file here for our Vue application, and we're telling Compose to find that in the Weather Report subdirectory. And then this depends on our two Python services, and we're going to map port 8080 locally to port 80 on this container. This Vue app itself will be built, and then the static files there will get served using another nginx instance directly in its own container here. So we'll take a look at that in a moment. Then we have our two simple Python services. Here we'll be running Flask APIs with just some bare bones simple demonstration endpoints. But one service will be responsible for retrieving the temperature and the other for the precipitation. And we will name these images appropriately and give them each their own build context with their own Docker files in the subdirectories that we have for them. The temperature service will be running on port 5001 and accessible on port 5001. This is just an arbitrary number in the container. We could, of course, run both of these APIs just like on port 5000 in the container. Doesn't matter because we're actually getting them mapped to 5001 and 5002, which are different ports locally. But just for consistency here, we're going to run this API on port 5001 in its own container and the precipitation service API on 5002. And then we will restart on failure for each of our three services here that comprise our application. Okay, so that was kind of a lot at once if you're unfamiliar with Docker Compose, but this is actually a pretty simple Docker Compose file. If this were for a production application, then there would be probably a bit more that would go into this. We would want to do things like set environment variables that we can do here, or we can read from environment files rather, so that wherever we deploy this, we could just read from some environment variable file to specify things that each of the apps needs to actually run. Okay, so now let's head into our reverse proxy subdirectory. And here we just need a single file. This is going to be used for the volume mapping that we have for our reverse proxy service, which is just running that base pre-built or predefined, I should say, nginx image for us. So let's take a look at our nginx.conf for our reverse proxy. So we have a bare bones nginx.conf here. This is definitely not production ready. For a production level application, there would be much more going on here typically, especially in terms of things like SSL termination and performance considerations, user permissions, and anything else that's really necessary to configure a production grade server, which nginx is definitely capable of. This demonstration is really just to show you what's needed to set up a bare bones reverse proxy, just to kind of get a sense for how this would work. And so we'll start with a user directive www data. So this is just saying that the user www data in the context where this is deployed on whatever Unix system that is, will act on behalf of www data user. So anything that this user has access to is available to nginx. We're setting worker processes to auto, which is a decent starting point. This would also be tuned most likely and would depend on things like the number of cores available on the machine and other system resources. We're using the PID directive here to define the file that stores the process ID of the main process, and we are including etc nginx modules enabled star.conf. So we're in a sense including anything that matches this wildcard.conf path. In the events context, we are including worker connections, or setting worker connections rather, to 1024. Something to keep in mind here is that this number refers not only to the number of client connections to our server, but really all of the connections that our server is managing. And so just something worth keeping in mind here. And now we get to our HTTP context. This is where we actually set up our reverse proxy. So we have a single server block here, and we're going to listen on port 80 to server name localhost 127.0.0.1. So when we visit localhost port 80 in our browser, Docker Compose is going to map that to port 80 in the container, and nginx is listening on that port 80. And then it's going to serve us one of three things. And again, this is not configured completely, but basically we're just defining three separate routes here that nginx will then proxy our requests to. So if we hit location /, then it's going to pass our request to weather report 80. So what is happening here? Because this looks kind of interesting. We have this sort of hostname weather report. And so how is this working? Well, this works because of the Docker Compose network. So when we take a look at Docker Compose, we've defined a set of services in our Docker Compose file, and by default, Docker Compose is going to network each of these services together. And in doing so, it allows us to access any of these services that are networked together within that network by their service name. So our reverse proxy service can basically reach weather report and temperature service and Precip service using its container name, or its service name here rather. So if we take a look, we have weather report on port 80, temperature service we're accessing at port 5001, and Precip service at port 5002. So in our browser, when we hit localhost, in this case, we don't even need to specify port 80 because it's implicitly the HTTP port. So if we hit localhost / nginx is going to proxy our request to our weather report service on port 80. So if we take a look here, we're going to expose port 80 on the weather report service, and it's going to serve up our Vue application. We'll have another nginx.conf for serving up our static web app. We can set a proxy set header here, x forwarded for from the remote address, and we'll do that for each of these various locations. But note the pattern is the same here. If we visit localhost at port 80 and then hit /temperature as an endpoint, this is going to route that request to our temperature service port 5001, which will be our Flask application returning results for temperature. Likewise, if we hit /precipitation, we're going to route this to our precipitation service. Okay, so that is really as simple as it gets in terms of a bare bones reverse proxy. Again, not production ready, but it will suffice for the purposes of this demo. So now let's go into our temperature service. And here we need to do a number of different things. It's worth keeping in mind how we set up our Docker Compose here. So if we take a look at our temperature service, we're expecting a build context of this temperature service directory to exist. And for this, we need to create a Dockerfile. So let's take a look at our temperature service Dockerfile. Here we have essentially a set of instructions for Docker to run when it builds our container. So we're going to use a Python 3.7 Alpine base image. If you're unfamiliar with Alpine, this is just a really lightweight Linux distribution that's used for typically for small containerized applications and services. We're going to set a working directory of /app, so all of the subsequent commands we have here containing relative paths will be relative to our app working directory. We're going to copy a requirements.txt file into our working directory and then run a Python command here, pip install -r requirements.txt. And so all this is doing is installing Flask. So our requirements.txt file has Flask = 1.1.2. And then we have a subsequent copy command here to copy all of the remaining files into that container. And the reason we have two copy commands here is because as Docker reads through the Dockerfile, it is going to create a sort of like layered approach where we have these cached image layers. And so this way, if we've already done something that may take some additional time to do in the future, if we were to do it over again, we don't need to do it over again if there were no changes, then Docker can recognize that it already has an image essentially cached at that point and can just reuse it. So we would, typically break this up line by line in terms of how we want to cache the various actions that we perform when we are building our image. And then we're going to expose port 5001 and then finally run Python temperature server, which is going to run our temperature server app. And here we have a bare bones Flask application we set the variable app to a new instance of Flask, and then at the route / here, we're just simply going to have a sort of mock temperature reading. And so we're going to set temperature C to some random integer between -10 and 33. And then we're going to return as a Python dictionary here the temperature C as a key, and then its value that we simply generated. And then finally, when we run this particular module as an app, we are going to run it on the loopback address here, just localhost and port 5001. So note that this port 5001, of course, has to correspond with the port we're exposing, telling Docker to expose here. And in our Docker compose file, to bring it full circle, we're mapping port 5001 locally to port 5001 on that container. Now, depending on how we choose to architect our application, it's not really even necessary if we don't need to hit this API from our local machine. If it only needs to basically communicate with other services it's networked with, then we wouldn't even need to map a local port here. Just doing it here for convenience and things like debugging. Okay, so that is our temperature service. Let's take a look at our Precip service, which is going to look extremely similar. We have a very almost identical Docker file with the exception of we're exposing 5002 and we're running the precip server.py file. Our requirements are the same, and the Precip server itself here is actually a bit different. So we are still creating a simple Flask application with a single endpoint, and it's going to invoke this getPrecipitation method. And so we've got the temperature C set to the integer conversion of getting the query string parameter temp. So the way that this is going to work is when we invoke the endpoint / here in the browser, we could do something like temp, and then we could say like temp is 20 or temp is some number here as a query parameter. And we are going to convert that to an integer and allow this to, or allow our function rather to use that temperature when it does its subsequent business logic here. So this is pretty contrived, obviously, but I thought this would be something more interesting than just putting out some static data. There's no query string validation here or request validation whatsoever. So of course, it's fragile. It's, again, just for demonstration purposes. So we say if that temperature is not provided, then we're just going to set the temperature value here to 23. The precipitation service is only going to use the temperature to print out whether the precipitation type is snow, storms, or rain. So we create some Boolean values here to check on those. And then we create a %chance here, just using a random value between 0 and 1 times 100. And then we're going to return that data as a Python dictionary here. It gets converted to JSON in the response. And that is essentially the complete business logic of our demo precipitation service. And again, we're going to run on loopback at port 5002 here. Okay, so we have our two Python Flask applications. And then let's take a look at our weather report application. So this is a Vue app. And so I'll show you how I created this Vue application very quickly using the Vue CLI. I just ran the command vue create weather report. Again, this is using the Vue CLI, which you can find and download if you don't have it. It makes creating a Vue app much easier than it would be to create from scratch, just by generating and scaffolding out the sort of typical structure of a Vue application for you. Okay, so I've modified that slightly. So if you create the sort of default templated Vue CLI application, then you'll find in the source directory here a hello world component. And so I've modified the template. The top third here, if you will, of this hello world.vue file is our template. And so I'm just putting out a simple heading weather report. And then we are going to do some interpolation here with these string templates, saying the temperature will be temperature and the chance of precip type is precip chance. And so then if we come down to our script area, I'm using Axios, probably overkill for the purposes of this demo, but Axios is a popular library used for making HTTP requests. And so if this isn't installed for your app already, then here we can just run npm install Axios and make sure that gets installed for our Vue app. So with this imported, the only other changes that I've made here are to the data, for which I'm just setting some initial values for temperature, precip type, and precip chance, and then invoking a lifecycle hook mounted and only using async here so that I can use await on Axios without promise chaining. And essentially what we're going to do is hit localhost / temperature. And then from that result, we're going to pull off that temperature C value. So if we head back to our temperature service just to refresh on how that's working, this is going to return an object with temperature C as a key and temperature C as value that it calculated. So then we will otherwise just console error on error. But what we're doing is we're going to set the value of this temperature data to the value that we get back from our service. And then likewise, we have this Axios, await Axios get, and we're going to now invoke localhost / precipitation with a temp query string parameter, and we're going to pass it this .temperature, which we just got from our temperature API. And then we're going there. This is kind of weird and a little bit sloppy, but I'll talk about that in a moment. Anyway, when we get the result there, we're going to set the precipitation chance and precip type from the data that we get back from our precipitation service. And again, to get a refresher there, we can see that we're returning this Python dictionary, which gets converted to JSON, and we just have these two keys in our object, precip chance and type. Okay, so let's just save all. Okay, and then why did I say that this is kind of a weird setup? Well, it is a silly example, but one thing I wanted to demonstrate is having a single front-end app interact with two endpoints on the same host, each of which are now pointing to two completely separate containers running two completely different applications. Typically what we might do here in order to sort of reduce surface area and only make one HTTP request, we'll probably have a service maybe just baked into temperature service, or have another service that sort of assembles this data. But we might want to do something like just like get report or something, and have this one endpoint then communicate with any other backend service it needs to assemble the data it needs to actually provide the front-end client with what it needs. But again, making two HTTP requests here just for demonstration purposes. All right, I didn't really change anything else here. And in fact, you could run the Vue app now just by, again, using the Vue CLI or just yarn run serve. And then let's take a look at how we can actually serve this Vue app more properly, if you will. And we want to Dockerize it, and we want to serve this Vue app, the static files for it up, using nginx itself. And so for this, first of all, we have a Dockerfile here. What I've done here is really just taken the standard suggestion from the Vue documentation about how you might have a multi-stage build here for containerizing your Vue application. We can see that we're using a multi-stage build here with Node as our base image. We're calling this the build stage, setting our working directory, copying package.json and package.lock.json into the working directory, running npm install, and then copying all of those files directly into our container, and then running npm run build. So here we are essentially just building out that dist directory that we get when we build our Vue app, that dist directory containing the static files that we need to serve to the client. And then we have our production stage. So here we are building this one on top of the nginx base image. This is actually the same base image except for the possibly for the version here that we're using for our reverse proxy. But this nginx container or image here is going to be used to serve up our app directory. So we're just copying, or rather we're making an app directory for the container here. And then from our build stage that was just completed, we are going to copy from app/dist those static files into our app directory. And then we are going to copy an nginx.conf from here into the etc nginx.conf location that is, of course, on our nginx base image. And so this means that we have another local nginx.conf here for serving our Vue application. So let's take a look at that one. So there's a little bit more going on here. Again, you can find good examples of how to set something up like this. Just looking through the Vue documentation, it's excellent. Here we're using nginx user with one worker process. We have the error log set here to warn, and the process ID name, which is the same. And then in the events context, we are setting 1024 worker connections again. And then in our HTTP context here, we are including etc nginx MIME types. We're setting the default type to application octet stream. What this is going to do is when nginx here will be serving static files, if it gets something for which it doesn't know the MIME type, then it's going to force the browser or request that the browser downloads the file as opposed to try to render it or display it in the browser window. We've got some log formatting, access log, send file on, keep alive timeout 65. And then the really interesting part for this nginx.conf serving our Vue app is the server block, which is listening on port 80, and the root of which is our app, which is where we copied all of those static files to serve. And then at location / here, we're going to be serving our index.html file. This try files with the URI/index.html. This would be necessary if we're doing history mode routing. We don't actually have any routes in our application except for the base route, so it's not really necessary here. And then we have like a custom error page and that sort of thing. But really we're just basically serving up this built Vue app on port 80 from this container. Okay, so with that, I think I have worked through all of the basic parts of the application. Now we can sort of demo it by using some simple Docker compose commands. So if I run docker compose build, this is going to build our application. This may take some time on your computer, especially if you don't have these images locally, the base images, that is. And now I'm going to run docker compose up. Okay, so we can see some logs already from our Precip service and our temperature service. You can see Precip is running on 5002 and temperature on 5001. It's giving us lots of warnings that we are using a development server, which is true, and then we have our weather report service showing us some logs here as well. Access logs actually, because I have a window open. So let's go take a look at that window. So in fact, if we just visit localhost, we should see our application, because again, this is implicitly running on localhost 80. And if we refresh the page a few times, we can see that we're getting a new random value out for our temperature. And it looks like we might have a bug in our precipitation service that we can go ahead and fix here, because I'm only seeing the value 80 come out here. Let's go ahead and inspect. And yeah, we're getting a 500 error at /precipitation. So it's kind of cool to be able to demonstrate this in a way, because we can do a real bug fix here. Let's see what happens if I just visit precipitation. So we get our internal server error here. If I visit temperature, we are getting a valid temperature out. So let's see what's happening with our Precip service. In fact, if we take a look at the logs from Docker Compose here, I'm seeing that the name request is not defined. So let's go ahead and fix that bug really quickly. If we go into Precip server and It's upset that we're using a request here without importing it from Flask, so we're just missing an import. And so with that, let's spin our containers down and then spin them back up again. So we can Control C here. We could also run these as a background process or daemon process if we needed to, but it's nice to have the logs here when we are debugging. Now we will simply docker compose build, and I'll run both commands here, docker compose up. Okay, so we are running, and let's go give our application another shot. Okay, so now we're back at our application. We're not seeing any errors in the console, and let's refresh a few times. And note that when we have a certain threshold hit for the temperature, we are now getting a kind of funny format here, but we are getting storms as the precipitation type, and then 3 instead of like 3%. The chance of storms is 80, so that's kind of funny. We would clean this up and make this, we could put a % sign there, for instance, to go ahead and clean it up. Let's see if we can get some snow. Yeah, there we go. So temperature will be -1 and the chance of snow is 12. Don't you love it when the chance of snow is 12? Okay, so that's a basic reverse proxy for routing traffic to a couple of different backend services utilizing Docker Compose for some simple orchestration. Now in production, we would have probably a much more complex nginx.conf setup and a little bit more work put into things like orchestration and security. In this video, I just kind of wanted to demonstrate how the pieces are sort of wired up together and to present a somewhat realistic example in terms of at least how we can route requests between servers sitting behind nginx as a reverse proxy. If you enjoyed this video, I would really appreciate it if you liked and subscribed, and as always, thank you for watching.